Hey guys, how's it going? I hope everyone is doing all right. So today we are actually going to be finishing multiplayer. I know I said that in the last stream too, but I promise it's going to happen for real this time. So, because I'm basically almost there already. So yeah. Langors, Tree, and CGO Clan, or Mr. Hecker, how's it going? Hope you guys are all doing all right. I am doing fine too. Just woke up and I was like, I should probably stream today and go over what I did to actually fix the multiplayer stuff. Which I feel like that's what these streams are becoming more of, is just like, here's what I did to fix what I was supposed to do in the last stream. It didn't actually finish. So hopefully you guys still enjoy that. But yeah, anyways, I'll go over what I did to actually get multiplayer working. First, we'll take a look at it really quickly, wait for a few more people to join, and then we can go ahead and take a look at it again when some more people join. But basically, we now have a way to join a world. So I'm joining on this side, and then you can see there's another entity here. Ideally, it would be good if we didn't actually have him here, since I'm just single player right now. He should only pop in when he actually joins, but for now he's here. There's no other entity that I used to have for testing, but then I'll start a server and I will join from here. And this isn't a true LAN server. Looks like I'm stuck. So yeah. So now you can see like I'm moving around, and you can see it's moving around on the server. And also notice how smooth it is on the server. And that's because the server isn't waiting for a response time. Since this guy is like acting as the server, he basically gets the commands immediately and he doesn't have to wait for a response time. Whereas this guy does have to wait for a response time since he's connected. So you can see it looks a little bit more jittery on his side. And I think that might be what we're going to work on today, is basically fixing that jitteriness and doing lag compensation, which is a kind of complicated thing, but it should be pretty easy now that I sort of understand what I have to do. There's a couple other odds and ends we need to fix, like it's the wrong time here compared to this world, so that's not good. And then you can also see, like, if I say give at me, I can give myself blocks. So I'll say give myself some stone. Some stone popped up in my inventory, and then we can give him blocks too, since he's a player. We can say give at external client player, which is his name. We'll eventually have like a way to actually authenticate users and get usernames and all that stuff in there. And we can give him stone too. And you'll notice it just popped up over there for him. So then now he has stone. So yeah, you can give people stuff. These commands are truly going across. And we might take away at how this stuff works by rerouting the chat. Right now the chat is going through a different method than I sort of settled on. So we can like fix this to go through the proper channels, just to sort of see how it works and get an idea of how the multiplayer stuff is going. But yeah, once he disconnects, we need to do a few more things too, because it's not saving stuff like inventory. It's also not doing any sort of cheat checking. So these things are just being trusted blindly from whatever the client says, which isn't good, but I don't care about that right now. I just want to get it working for now. So yeah, I'm going to read through the chats real quick. And there's a sad reason your name is Hecker, because you used to create IP logger links every day and spamming them in random servers. So you changed your name to Hecker. So I have a middle entity receiving all the packets and sending them. Kind of. So that's, I guess, eNet is the library I'm using, but it's not really doing that. We'll talk about them. Or do you just send them to every player? We do just send them to like every player, sort of. It's a little bit weird if you're like a player, but you're also acting as the server, because it's a slightly different use case. And we'll kind of go over that too when we talk about how all this works. I also have this weird double abstraction layer that I'm not quite sure I like, but it's there. And I might get rid of it soon. So basically, let's talk about this. What happens when we want to send stuff to server and send stuff from server back to client? Say we're the player controller, for example, and we just moved and we want to send our updated position. So what do we do? Well, if we look at the player controller, what we do is we basically say up where I have the position, somewhere up here, all the way up here. Okay. So what we do is we say data equals, and so we get the data we want to pass, which if we're updating a position, we want to say we want to update their vec3, which is their position. So we send a position and the player ID. That way the server can tell who just updated themselves. And like I said, there's no cheat checking right now, but we will get to that eventually. And then I basically say send a user command. And This is where I'm taking from Quake 3. So I found this great article. Let's get out of Inception mode here. Okay, so I found this great article. I'll link it real quick too for you guys. Quake 3 Network Protocol, which basically takes a look at the way John Carmack sort of set up Quake 3's code. And he was programming netcode in like mid 2000s when did Quake 3 come out? Let's see. Quake 3 release date. Not release data. Okay, 1999. Whoa, I didn't realize it was before Doom and stuff. Is that? I think that's before Doom. I don't know. I don't know what I'm talking about. But anyways, this came out in 1999. So as you can imagine, network latency was horrible, right? If you're doing stuff over the network, you need to come up with a really good system. And so I feel like this is a great thing to look at because it gives you kind of a good grasp of how to handle netcode in a way that's going to be fast even on the lowest end of systems, because our lowest end of systems are pretty much like their highest end networking systems were in 1999. So yeah, Doug the Coder, good to see you. Came here from recent promoted YouTube video from the Minecraft series. Nice. From the Minecraft teaching series or from the Minecraft video, because there's a few of them, but that's cool. And they released Wolfenstein, then Doom, then Quake. Okay. Cool. So Doom came out even earlier. I thought that was like in 2000s. I guess they released like the later Dooms, but there's also a great book too. This is completely side tangent, but, oh, sweet. Thanks for following, Isa CDev. Thank you. I think it's called Masters of Doom. Yeah, this is the one. Okay. Get this book if you haven't already, because it's freaking amazing. Okay. It basically just tells the story kind of more from a biographical standpoint than like a technical standpoint of how John Carmack and John Romero basically created Doom, and it's just really good. So all around good book. It's interesting reading about these guys because they were probably close to my age, which is also just interesting to read about and stuff. But yeah. Okay, so you love Masters of Doom. Listen to the audiobook narrated by Will Wheaton. Nice. Girlfriend, nice to see you. This isn't Valorant. No, it is not Valorant. Okay, anyways, that was a side tangent. What was I talking about? I think I was talking about multiplayer stuff, right? So this thing helped me out tremendously because it basically gave me an idea, and like an idea of where I could begin. And I feel like it's really hard because when you read all this networking stuff, everyone is giving you the advice of like what you need to do to make the networking really good. They start telling you, oh, you can do this so that you can do anti-cheat. Oh, you need to do this so that you compensate for lag. Oh, you need to do this to make sure that the world state is like you interpolate whenever the player's doing this. Oh, you need to do this to predict where the player's going to be. And it was getting super overwhelming because I was like, I don't know how to do any of this. And then I found an answer. I think it's right here. No, I don't think this is one. I found some Stack Overflow answer, and it kind of hit me. He's like, dude, he's like, you can do all this stuff, all this, blah, 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 blah. And then he was like, but in the end, he's like, I would start with just like literally dumping your entity states to the network and then deserializing it. And I was like, oh, like, yeah, why don't I just start with the easiest thing there is? And so I finally did. This is what I decided to do. And once that clicked for me, for some reason, it was like, oh, this is a lot easier than I thought. But anyways, so what we do is we basically have these commands, and I guess it's not in here technically since this is the player controller. This is how we send the commands. It was somewhere in here until I lost it. Okay, yeah, so this is how we send commands. This is a different kind of command. Basically, this is for set blocks, right? I say set a block, and then I tell it the world position and the block type. That sends it to the server. Server is going to do stuff with it and then broadcast it to clients who need to know. But anyways, how does it work though? We have different types of commands, and this is kind of what I was doing before. I think I'm going to abstract it a little bit more into like this, and we'll kind of go from there. Dan Boxer, thank you for following. Good to see you. So we're going to sort of move this stuff into here because right now I kind of have like this double layer of abstraction since I was still figuring stuff out, and I don't like that. But it's fine because we'll fix it sometime. But anyways, these are the two important things. So we have user commands and we have client commands. User command is an unreliable message. So user command is anything like position, which is, it's fine if we drop those packets because that's going to be changing from frame to frame anyways, and we don't really care if we lose a couple of those packets. Client commands are more important stuff like setting blocks, removing blocks. Those are things we want to go through the network because they're important. Like we don't want to miss those commands because those could potentially affect the player's gameplay experience. So these are the two separate types of commands. And then within these commands, you can see I've got like update position, which is a user command because we don't care if we miss a few of those. Inside client commands, so far I have give, set block, and remove block, which are like important stuff. Let me just check too real quick. The DOM-L. Doom was the first game to implement various layer rendering in different height. Wolfenstein 3D technique just rendered simple layers all at the same height. Yeah, Doom was like the first true 3D thing, whereas Wolfenstein was basically just kind of like Mario Kart, I think, the original Mario Kart or something. And by that, I mean it was like all on the same height. Okay, but anyways, so we have these two different commands. That's sort of how we're going to wire everything together. You'll see they look basically the exact same thing. This is something I'm putting here for future reference. We're going to use a timestamp with all of our commands too, so that we can actually play things out from the past in the future, because that's going to be the best way to do it. And in order to do that, we need to know the timestamp of when a command happened, and then we can sort of get the delta time from that and all that too. That's later though. Then we have network, and so this is how we send the different kinds of commands, right? We say send a user command, we give it the type, we give it the memory, which is just any arbitrary memory, and then optionally you can give it a peer, somebody who you want to send it to. And then you can send client commands, basically the same whole thing. And we'll take a look at how all these work in the actual network. What does it do? So the network, it does the same thing for user commands and client commands. It basically packs all the data together into one big block of memory. That way we can send it in one packet, and then I do additional packing of the data to send it appropriately with this thing. But basically then I say, okay, send it. So if we're not a server, then send it to the server, and we say it's a user command. Otherwise, we say if we are the server and we want to send it to a specific peer, we send that to that specific peer. Otherwise, we just broadcast the command to all the clients. So you might want to do this in cases where like the user sends a set block command, but they've already set that block on the client side. So you don't want to resend that to them because then it's like duplicating that command twice on their side. So you would rather just send it to individual clients who need to know about that. But yeah. Also, thank you for following MC Mojangster. Good to see you. So, no, you hosted me, I think. Thank you for hosting me. Not sure what that means, but I just see it in the feed, so. Okay, so. Yeah, so this is how it works. Let's dig into a concrete example and switch up the chat from being what it currently is, which is just a basic command here, to being a client command type. So what I'm going to do is I'm going to say, let's remove chat from here. This is a message that we want to be reliable, so I'm going to put it in here. We want the chat to go through because that's an important message that probably shouldn't be dropped. I think it will drop stuff too. Like eNet will just drop some of these packets if it tries a certain amount of times and it doesn't actually succeed, but we don't have to worry about that for now, at least. Okay, so we send the chat. We want it to be reliable. So then what I would do is I would go into server.cpp, and I basically have this thing which goes and processes client commands, right? So what I can do is, actually, I think the better thing to start with is actually where we would send it, which is in the command line. So this is where we would actually send it, right here. So we basically say, or actually not right here. We basically first check to see if we're running a command when somebody types in enter on the command line. And then right here, if it's not a command, it's just a chat message. So what we say is we want to send that message. And this is what I was doing before. We're going to change this because I think it'll be better. Okay, so basically what do we want to do? Well, we want to send the actual chat message with the data. And this one's a little bit harder. I'm trying to think of what I want to do for this. Because strings are always kind of annoying. Okay, so this is actually going to be like a really special case because I think I'm going to have to go override some templates. Okay, so inside of core.h, I don't know if you guys saw this in Discord, But I basically created this helper thing, which basically just packs and unpacks arbitrary memory into some dynamic heap allocated memory. So that basically what I could do is I could say something like size data, or I guess sized memory data equals pack, and then I could say const char star, and, or actually I guess this would just be a char star. So char star and say we want to do size t, right? This is the length of the thing. And then what I could do is I could just say and buffer, I guess we could just say buffer, which will give us a char star. And then we could pass the size, which I guess is the message length. And we will go ahead and just copy that. But this isn't going to work right because char star is not good. What's wrong with this too, first of all? Oh, it's because I got to say and buffer 0. So we're just going to take the address of that. Okay, so basically what this is supposed to do is it's supposed to pass this or pack this string along with its length into this data. And it's not going to do that because of the way that I have this set up. So we'll fix this real quick first. And then we'll test it just to make sure it works right. So basically what we want to do is we want to add a special template overload for strings right here, which is this copy data by type thing. So I think I can just do something like template size t copy data by type un8 star dest size t offset and const char star data. Okay, I think this is what I would do, and I think this should override that. Let's see what this says. No instance of function template copy data by type matches. Oh, I think I might have to do like const char star. Okay, I think that's how you override templates. I'm not quite sure. So anyways, this is just like a special case. I didn't expect it to turn into this, but where we want to copy the whole string instead of just copying the pointer, which wouldn't be good. So what we can do here is we can say stud string. Actually, and what we could do is we can make this super smart where we don't even have to do this. We could just pack that string and then it's going to automatically pack the length with it. Yeah, but I don't like that. Never mind. Okay, we're going to do this. Also, thank you for following TR4CXing. Traffic crossing? I don't know. But thank you for following. How's it going, Sam? Good to see you. Okay, so basically we want to specialize this template. What we're going to say is, first of all, get the message length. So we'll say length of string equals stud string length data. So we'll do that, and then what we shall do. Oh, and we also need to make sure that our size of operator fixes this too. So we need to specialize. Okay, so we need to do a couple of specializations. First, we're going to say template, type name, t, size of, I guess we'll say void size of, or no, that's size t, type, and then this will return size of type. So we'll say return size of t. And then here, what we're going to do is we're going to say return size of type first. Okay, that way we can specialize this. And then I'm going to go ahead and say size t size of type. And this is going to be for char star. Oh, but this is going to be, This is kind of annoying because then I need to pass the string through here. Okay, sorry, this wasn't even supposed to be what we were doing, but now I'm trying to fix this and everything because I want this to work the way it should. So I guess the simplest thing I could do is just pass this stuff through. Okay, so what we're going to do is move this up into here because I don't want this to be public stuff. So I'll put it in here, and then we're going to say template const char star, and this is going to take in const char star string. Okay, and then this will just return stud string length of the string plus 1 because we need 1 byte for our null byte. Okay, and then this will just return const t ref t, and it doesn't really need to do anything with the type there. Okay, and then this will take in first, and rest, rest. Okay. I think this is what we want Yes. And then what we're going to do is we're going to pass first here, and then we're going to pass rest ... here. Okay. We're going to have to check and make sure this works because I'm not sure if it is. And then right here, what we're going to do is, actually, I might have done this wrong. I might be able to, no, yeah, that's fine. Okay. And then what we're going to do here is say data ... Okay. And I think this should be good. So now we get the proper size of that string, and we can copy the memory into here safely without having to worry about that overwriting more memory than we allocated. Okay. So then for the destination, that's where it's going to go. And then we're going to say star, char star, dest data equals data. No, that's not what we want to do. And then what we're going to do is we're going to say stood string copy. Destination is dest and source is data. And that should copy the string. And then we'll say dest data length of string equals null byte. Okay, so that should copy it, I think. And then we're going to return length of string +1, which should increment it so that the next thing gets packed after that. Let's see if this works. So basically what I was doing here is I basically wanted a way that we could do something like this, which we'll see in a minute. So I could do something like pack sized memory data equals pack char star int float, and then I could say hello world 3.14. Okay, and then I basically want to be able to say char star string int a and float b, and then I want to say unpack char star int float, and then we pass it data, and we pass it a string a b. Okay, and that should unpack it. Let's see what this says. Did I do this wrong? Unpack size memory types star. That's what I want to be able to do. I don't think this is going to work right. I'm probably overcomplicating this. So actually, let's just ditch this whole thing and ignore that I ever started doing this. I'm going to just undo all this stuff, and then we're going to move on. Champ Guacamole, thank you for following. Good to see you. Okay, so pretend that didn't happen. Let's go back. What were we trying to do? We were trying to simply say we want to broadcast a string across the network. So instead of doing all this stuff, what I'm going to do is I'm going to say size data equals g memory allocate, and we're going to take the message length +1. And technically this is times size of char, which should just be 1 anyways, but I like including it just because. Okay, so, and I guess we'll just call this uint 8 star, and we'll just do uint 8 star, and we're good. So we allocate memory for the string, and then we're just going to say stood string copy buffer to the data. So we want to say data, and then we want to say and buffer 0. And we need to cast that to void star, because that's what it wants. Or actually, I guess just char star. Same thing, but it's fine. Okay, so we're going to do string copy, and then we're going to say data message length equals \0. Okay, so we basically copy the string there, and then what we can do is we can say sized memory equals data and message length. Oh, and I don't need that +1 there, do I now? Because that's already in the message length. Okay, and I think we should be good there. And I should probably make this message length -1. Okay, that was off by 1 error. Anyways, so this is what we're going to do, and then we can say network send client command type chat. Okay, and then we want the size data, which is our memory, and we're not sending it to any specific peer. Now, if we were doing whispering or something, maybe we want to add that there. We can get rid of that stuff now. but we're not. So we're not going to worry about that for now. So I think I need to free this memory too right after I send the command, because I think that copies it. Let me just double check on that real quickly. Yes. Okay. So then I free the memory afterwards because we don't have to worry about that anymore. So we'll say free memory.memory, and we're good. Cool. So we just sent a client command with the data that is just the string that we want to send across, right? Oh, I think you guys were talking about when I was trying to pack and unpack. Yeah, I'm going to give up on that for now because I don't want to think about templates and stuff right now. So we're not going to think about that. But yeah, so we send this across the client. And then what happens when the client receives it? So that's the next step, right? So when the server receives it, what do we want to do? So basically the client has just sent a chat message to the server. But there's also the case where what if this client was acting like the server, right? Because technically what could happen is I'm hosting the game, a LAN server on my own computer. And so when I send this message, I'm technically the server. So we have to sort of think about both those cases, which gets handled automatically in the network, right? So what the network is going to do is it's going to say, oh, if this was a client, send it to the server. Otherwise, if this was the server, broadcast it to all the clients. So this kind of already handles that case for us. So we know that if we're in the network code, or I mean in the server code, that this was just sent from a client. It had to have been. So we are good there. And then what we can say is client command type, which is the next one we want to handle, chat. So we want to handle client command type chat. We'll say break. Why is my auto completion being weird? I'm just going to copy this for now because it kind of gives us a method to go off of. Yeah, it's being really weird. Okay. Anyways, so what we do is now we're going to get a command which basically contains some size memory, right? So this sized memory is going to be the same thing that we just sent over here. So it's literally just going to be our message with a null terminator. And then the length is going to be the length with the null terminator included. So that's actually kind of good. But yeah, Yuma117, thank you for following. Good to see you. So on the server side, we know that what's in here is actually a string. This is all unsafe stuff, but if you're going to be doing network stuff, it's going to be unsafe anyways because you're just dealing with raw binary that's getting sent across the network. So there's not really much you can do. This unpack method does do some bounds checking to make sure you're not going to like overwrite data. But for these messages, I can't really do that as easily. But anyways, what we'll say is we'll say char star message equals, literally we can just say char star client command data, which should be the message. And I actually don't really even need to do this or that. Okay, so we got this char star message, and then what we can do is we can say what we said before somewhere up here, which I think we were just logging it out. Yeah, so before we were just logging it out, so we'll do the same thing. And I'm actually gonna remove this since we're switching it from being a basic command to a client command. So then right here, we'll just say log a server message. So this technically isn't a server message. Actually, this is technically coming from a client. So we can say client message, and then we'll put the client's name in quotes. And I guess it would probably be good to send the player ID with this stuff. Yeah, it would probably be good to send the player ID with this stuff. So we'll add that in a minute. For now, let's just try and send the message, and then we can send the player ID too. That way we can identify who sent the message, which is important. So we do that. We're just going to say log that info, and this is actually going to be that. And then you can see I have these to-dos here just to remind myself. Do cheat checking and do lag compensation. We can remove all this. But if a client sent a message to the server, then the server also wants to send it out to all the other clients who were not the one that sent it to me. So basically, I just go through all the clients that are connected, and I say, okay, this is who we might send it to. But then I say, okay, if the peer that we want to send it to is not equal to the guy who just sent this message to me, so we're not resending him the message he just sent to us, then send it to that guy too. So then right here, what we're going to do is we just say that and command size of data. which should be good. Size data. Oh, this is expecting a size memory thing. So what we can do is we can just say client command data that and cast this to a UN 8 star. Okay. And I guess that would be command size of data. Yeah, so I guess this kind of was important, but it's not too important. Let's just copy it here so that I have it, because I probably will need it in a minute. And then we'll just do that here instead. Okay, so then he sends it to everyone else. Now, we have to handle client side as well. What happens when the client receives a message? Well, we basically do the same thing. So there's probably some duplication that I could probably remove here, but I like keeping it separate for now because it just makes it easier. Let's remove that. So if we go onto this side, when we're processing a client command, we can paste that. If it's a chat command, then we get it. This is coming from the server. Of course, we'll get the actual name of the user who sent it in the message in a little bit. But for now, we'll just do that. And that should be it. So I made that sound way more complicated than it actually is. It's actually, we really just changed like this file, and added this, and then this file and added this. That's all it was to add chats that actually go across the network. So let's see if this works. SC Woods, never understood how people cheat online. I am the same way, but I think it is basically you send, I think it's like you hack your client side of the game, and then the game starts sending invalid data to the server. And if the server just accepts whatever the client sends them, then that's basically cheating, right? So it's like if I hacked my game on my computer and said, and I was running cheats or whatever on my game through some cheat enabler or whatever, then I say, oh yeah, I just like teleported myself to this place. And then say the client sends that to the server, and then the server is just like blindly accepting that. And he's like, oh yeah, this player's over here now somehow. Then you got cheats. But you can do some stuff to like basically, which we're going to do eventually, basically ensure that like the player's speed and everything match are close enough to where he should end up in the time frame that actually happened. So yeah. Okay, so let's see if this actually works. We'll hit play game here. Drag that up here. So this is going to be our server. This is our client. Whoops, did not mean to break that. Okay, so we'll say start a server here. We'll say join a server here. Okay, so we are now joined. And then if I say something, hey, what's up? You can see we just got a message over here and it says client message, hey, what's up? And you'll notice we didn't get it over here because we just sent that message. It makes no sense to get the message that we just sent ourselves. So then if I send a message back, I can say, how's it going? And we get server message over here, no server message here. So it's all working all right. We can now send messages back and forth. But let's say, which we actually do want to do this because it's a good idea. Let's say we want to send the player's ID with this stuff because we need to know who's saying what. It makes no sense to just send this stuff without actually saying, oh yeah, Games with Gabe sent that or whatever, right? We need to actually do that. And I do have a very primitive authentication scheme right now, as in it doesn't exist at all. What I'm doing right now is I'm just saying if you join from a client, well, actually, okay, if we go into here, yeah. So we say if you join from like a single player world, we're literally just setting your username to local player just to simulate this, because I'll add authentication everything in the future, but for now I just need a way to make sure it works, right? And I have a bad problem of like delving too far into a detail without actually checking to see if it's necessary. Yakto MNS, thank you for following. It's good to see you. So, and then on the server, we basically do the same thing, except the server's name is always external client player. And so basically what this does is it checks to see if there's already an entity in the world that has that name. And if not, then it creates it. And then we basically hand that out to whoever just joined. So yeah. Okay. So yeah, we have some primitive authentication. We want to send that authentication across. We can get the ID by saying world get local player, which will tell us who our player is. Like, so if this is the server, it'll return whoever the server's player is, but this should only be handled from somebody who's actually playing the game. So this will only work if it's like, if it's a standalone server, then this will never get called because a standalone server won't have people typing in stuff on it. So this is only if it's like a shared server. And if it's a client, it'll just get whoever the client is. Okay, so we can get that player, and then we can say ECS entity ID, local player equals that. CGO clan, send through server. If position is changed abnormally fast, then you make a list of player near the cheating player and then ask all of them to send current position cheating player. If position is changed abnormally in the clients on player's cheating, you can ban them. Yeah, that's one way to do it, but we can actually, we'll have to store the history up to a 1/10 of a second anyways. So we can actually just check the server's authoritative source of truth and say, oh, does this make sense? Okay, yeah, it does. Or if it doesn't, be like, oh, no, that doesn't make sense. He shouldn't have moved that far. So we'll kind of do it that way too. But yeah. Okay. So we've got the local player, and now we just want to basically combine this to our data here. So we need to basically increase the size of this data thing. So the way I'm going to do this is it's going to be the string followed by the entity ID, because I think that's just the easiest way to do this. So what we'll do is we'll say sized memory. Memory equals sized memory, and then we'll pass it the size we want, which is, I think, wait, let me just double check this. Okay, memory, then size. So we'll pass it the memory. So we're going to say size t size of message equals size of ECS entity ID plus, and then we also need to do that. So we'll do that, and that should be good. And then we're going to move message length up here. Cool. And this is kind of ambiguous. So let's call this chat message length. And this message is like the message we're sending to the server. So I guess we should call this size a command. Okay, so we can get that size of the entity ID plus however long we need for the message length, which is this, and we'll call it that instead. So then size memory, what we can do is we can say allocate that. We will allocate size of command, and the size will be size of command. Okay. So that should give us like just a little memory wrapper, makes it a little bit easier. And then what we can do here is we can say data is instead of this just memory.memory, and we'll call that uint 8*. Or actually that already is. Okay, so we're good there. And then we can just copy it to the beginning of that block of memory. Chat message length will be null byte. And is that correct? Yeah, that's correct. So then what we can do is we can copy the entity ID to the end of this data. So what we'll say then is we'll say ECS entity ID star. We'll just interpret the end of that data as an entity ID pointer. Should we? Actually, I'll just do this. uint 8*. Entity ID dest equals data plus size of, or I guess plus message length, which we should do chat message length times size of char. Okay, so that should get us to the point we need to be, and then we can just copy our entity ID there. So we'll just say star entity ID dest. And I guess we need to interpret this as an entity ID, so we have to do this weird syntax, star, semicolon, ECS, entity ID star. So we cast it to an entity ID, and then we're dereferencing that. Entity ID dest equals, and then we're just going to pass whatever that was, which is local player. Okay, so we just copy that there. And then we can send this chat message using the memory that we just did, and then we'll free that memory after we're done. So that should be good. Let me just double check this stuff real quick too. Oh, okay. Looks like we're just talking about some more cheats and stuff. Yeah, there's some cheating you can't really detect too, which is like if somebody's using a auto aiming thing, which is just running locally, because technically it's legal and it's not really something you can detect because it's not going through the network. So some cheats are actually impossible to detect, and that's when you just have to have players who are like detect the cheating player, I guess, or whatever. Okay, so anyways, This is what we need to do. So now we should have that entity ID tacked on to the end of this message. So when we go into the server, we should be able to access that now, right? When we get the message, what we'll do is we will say, it's somewhere down here. Okay, yeah, so when we get the chat message, we also want to get that entity ID. So we'll say ECS entity ID star entity ID, or I guess we should say player, equals, and then we can get that from the end of the message, which is just going to be, we have to get the string length. So we'll say size t string length equals stood string length message plus 1. Okay, and then what we can do here is we can say size data dot memory plus string length times size of char. Okay, so that should get us to the point in memory we want to be. We'll just cast it directly to an entity ID star. Okay, so we should be good there. And then what we can do is we can now figure out who the player was, right? Because we have that here. And maybe we'll actually just copy that because it's the same size as a pointer anyways. So that's fine. Okay, so we have the player here. And we want to check and see, first of all, is this a valid player? Because if it's not a valid player, then don't really want to do anything anyway. So we want to say if player does not equal ECS null entity and player has component, or I guess we should say registry has component, player component, player. So we want to check and see if this is actually a player too. So we'll do all that, and we can get the registry just by saying ECS registry star registry equals scene get registry. Okay, so we check and see, is the player valid? If it is, then we're good. Then we're gonna say log info, and what we'll do is we'll say, instead of the client message, we'll say %s, and that %s, guess we don't need quotes too since we have the brackets. That %s is gonna be our player name, which we can get using our player component. So say player component ref, player component equals registry get component, player component, player. And then we can just log that here. .name. Okay, cool. And then we'll just forward it to the clients. For now, the clients won't actually receive it. Let's make sure this works, and then we'll implement this client side too. So we can test this now because it really doesn't matter if the client receives the whole thing. And then if this works, we can implement it on the client side too. So now if I go and say play game, load world, I'll move this over here. So this is our server. Keep breaking that. And then this is our client. Let's join. Okay, so now we're joined. Okay. I implemented this server side, so if I send a message here, we should see. So, hey, how's it going? Okay, we get a message over here, and we should see external client player. How's it going? Okay, cool. So now we're getting the player name sent along with, or I guess technically the player's ID, which is even better because then we can just get whatever the player's name is depending on that. If we do it from here, it's not going to change because we haven't added that functionality yet. So if we say, hey, still says server message. So let's go ahead and add that now really quickly, which should be pretty easy. Iceburn, thank you for following. Good to see you. So you see, multiplayer stuff doesn't have to be that hard, right? How's it going? It's good to see you, Iceburn. I was way overcomplicating it though, and it was becoming hard in my head. So yeah. Okay, so then let's just sort of add the same thing we did in the server here. We'll kind of grab all that stuff because that's what we need. And then we'll do that, and we should be able to just close that off, and we should be good. So we do the same thing. We get the data, we get the message, we go past the message length. And I'll put another to do in here because what would be good is to do, make sure I'm not going out of bounds memory here because this is network code. I should always check and see that I'm not exceeding my packet length because I could get corrupted packets or something like that. So to do is there. Specifically here, and here is where I want to make sure I'm not like doing something stupid. But yeah, let's see. So I'll probably want to make like a different function than string length because this will probably fail if it's corrupted data or something. Okay, so this should do the same thing. It's going to say the player's username and the message. Let's just make sure it works. And then if this is good, then we should be pretty much good with multiplayer stuff. Like, I guess the next step would be actually getting lag compensation stuff working, which we can start experimenting with, because I am interested. And then we also need to pass the time of day, because it's getting the wrong time of day right now. Okay, so I'm moving around. If I say, hey, or not as a message, hey, what's up? This says external client player. We are good there. And then if I go ahead and say, how's it going? This says, how's it going? Local player. Cool. So we are good. By the way, too, I don't know what the resolution looks like on this stuff for you guys on Twitch. So if these command prompts are like so small and you can't read it because of quality or whatever, just let me know and hopefully I'll change that and everything. CGO clan petition to implement the anti-cheat mention that you mentioned after multiplayer is fully done. Well, I'm going to do multi-cheat, but it's not going to be quite that way, because we can do it without having to depend on other players and stuff. Typically, when you implement an anti-cheat method, you don't want to depend on any of the clients, because all the clients could be corrupted. I guess that's like rule number 1 of network programming is don't trust the client. So the server is authoritative, and if the server is authoritative, then what you want to do is what we'll be doing for the lag compensation, actually, which is we'll basically be storing a list of these commands. And then once we pass a certain moment in time, we're actually going to be playing these out. So this is the next sort of thing that we're going to be doing. So I'll talk about this in just a minute, because I think this is the next step. For now, though, let's go ahead and push all this stuff, because I think this is good for now. So let me add that. Always good to add stuff once you get something working. So the other one, what if you check if the process is of a popular cheating tool and is running, and then if it is, then ban the user immediately. Oh, that one. I don't know. I'm not worried too much about cheating right now, so I just want to get it working right. And actually asking the OS about other running processes and stuff is a little bit harder than you would think, but just because the operating system doesn't like to, you have to use like operating system specific functions, which kind of makes it annoying and stuff, but yeah. Okay, so we add that stuff. We'll say move chat messages to be client commands. Okay, and then we'll say push. That colon was not necessary. It was accidental. Okay, exit. So we're good. We've got that pushed. Let me just double check though. So we should have nothing. We got nothing. Cool, we're good. So now we can start adding lag compensation. Let's talk about what that is first before we start implementing it using the drawing screen in a second. Okay, so let's switch over to here. Okay, you can ignore what's on this thing right now because that's kind of out of date. So what is lag compensation and why do we need it? Lag compensation is exactly what it sounds like. We're compensating for lag. So what we need to do is we need a method on our server that basically plays stuff out in the past for clients, because otherwise we get a bad experience, right? So let's take a concrete example, right? Say I'm in the US, which I am, and say you're in, I don't know, Australia, okay? So ping time from US to Australia is going to be some amount of time. And that amount of time is not going to be 60 frames per second, most likely. Like, I don't think it's possible to do that. So if I go from US to Australia and back, because that's what has to happen, right? Say I'm in the US and I say, hey, I just updated my position. So I say update position. And actually what really happens is there's probably a middleman somewhere, which is our server. And say our server is located in England, right? So our server is actually here. So what's probably a more accurate description? And Computer Flash, thank you for following. Good to see you. More accurate description is probably like we do something like this, right? That goes there, that goes there. And that increases the time even more because now we have to worry about all this stuff. So let's say I update my position, right? server gets this message after, I don't know, let's say like 20 milliseconds. This takes 20 milliseconds, right? Which probably won't really happen. That's a weird network patch. Japan would make more sense. Yeah, I don't know networking. I'm just putting these up for sake of example. So not realistic at all. I'm just saying, like, imagine that this is happening and we're in different places. Replace these with your preferred country. Okay. So then what we could do is we could just immediately send this to Australia. We say update position. This takes like another 20 milliseconds. Let's just say whatever. Okay, yeah. So round trip, it takes us 40 milliseconds to get from here to here. Theoretically, not really, because these are completely made up numbers. It's probably way different, right? So that's all good. But then let's say player in Australia also updates their message. So then they go send this to here. This sends it to here. That's another 40 milliseconds back. And all in all, it's just not good, because what's going to happen is if I just keep taking this stuff, and then let's throw in dropped packets and stuff now too. Yeah, so definitely not accurate time here. Let's throw in drop packets and everything too, right? So like we're dropping packets and everything. So we actually lose a few of these. We're missing data on our side. Now it's going to look more like there's like a few hundred milliseconds between these updates. And so what we end up looking like is we get a packet here, like say packet 0. We dropped a big group of packets. Then we get 1, 2, 3, 4, 5, packet 5. The time length between this is some amount of like big amount of milliseconds, right? 200 milliseconds, we'll say. Games run at 60 frames per second, right? We want our game to be able to run this in 16 milliseconds, right? That's how much we have per frame. So this would feel like this is like less than 5 frames per second. Not good. So basically what we need to do is we need to save these things, right? So instead of just sending stuff immediately, sending it immediately to all the players, what we need to do is we need to say, let's store an array of all these updates. So let's say this is where real time is. So this is the present. And then this is our buffer. So then we'll say this is the buffer start, right? This is our buffer start. And I'm saying this as much for myself as for you guys, because I really have to make sure this makes sense to me before I start implementing it. Otherwise, it's not going to work. Okay, so then let's say we store up a certain amount of bytes or a certain amount of time. I'm going to do time because I think that makes more sense and we don't have to worry about memory too much. Let's say we want to store up 200 milliseconds worth of buffer. So now we have 200 milliseconds worth of buffer. This data is not likely to be complete, which is fine. So we can have dropped packets here and then more stuff. Maybe we lost some more packets here. That's fine. More stuff. Now what we're going to do on the server side is every update, we're going to go from here and then we're just going to use whatever value is passed into here. And this is what we'll use for updating the player's position. We won't even pay attention to all the stuff that's happened here. So we're actually going to be playing everything 200 milliseconds in the past. And then what that enables us to do is say we have some drop packets here. Well, that's fine. We'll just grab the next one and then we'll interpolate, because theoretically these two should be one after the other. And so then we can interpolate between these and we can basically make sure that it looks like smooth movement and it looks like it's running at 60 frames per second because we basically queued up enough data to simulate that. And then as we increment this, then we also, present time is also getting new cues, new stuff. So that keeps going forwards as we keep going forwards here. So yeah, that's the technique we're going to use. We basically buffer up a lot of these commands and then we execute commands in the past instead of doing the stuff that's happening right now. So that's the plan. Let's see if it works. Makes you think about the entry on latency numbers every programmer should know. Send packet California, Netherlands to California, which is 150 milliseconds. Dang, okay. So California to Netherlands. Okay. And so this is something we can make configurable too, so that if you have servers in different parts of the world or whatever, and you want to queue up a higher amount of buffer, right, you can add in a bigger amount of buffer. So we kind of want to make this stuff configurable as well and everything. Did anyone else notice that the chat on stream is lagging? It's a bit off. Chat on stream is always lagging. You guys, like, the time it takes you to get your message to me and me to you is probably like half a second, if not more. According to the link at the moment, LA to Paris is 580 plus milliseconds. Dang. Okay. Yeah, so you can see why it's important to make sure that we add this buffer in and everything. And then we can talk about making it better in the future. For now, though, let's just, how would we do this? We need an array at the most basic thing, right? We just need an array, which is going to take in positions, right? Positions and entity IDs and timestamps, which is basically just this command. So what I'm going to do for now is I'm just going to implement it inside of the client itself. No, inside the network, the server. We don't want to implement this in the client. The client's going to just do like, it's going to assume that everything the server is sending it is just what it needs. Server is where we're going to buffer stuff. And Elon Musk thinks that we all want satellites for internet gamers. No, thank you. Yeah. Okay. So let's go ahead, and what we're going to do is add in our buffer here. This will be our internal buffers for now. Yeah. Zimz SSBU, thank you for following. Good to see you. Okay, so we'll say static UN8 star position buffer. I'm going to separate these buffers by the data type because I think that probably makes the most sense. And I probably don't want to store it as something like this. Let's actually make a structure to kind of encapsulate what this is because it will be easier to think about. And then we can move all this data out into some other things in the future, I guess. Okay, so let's say we have a position command. Update position command. What does this command contain? It contains basically the same stuff we have in here. We already know what type of command it is, so that doesn't really matter, but it does contain the timestamp and a couple other things that we don't need in here. So we need the timestamp. We also need glmvec3, the position that it was updated to, and the entity that it's acting on. So we'll do that. Then what we're going to have here is a buffer of those. So we'll say update position command star buffer. I guess we can call this position command buffer. Okay, so we'll have all that. And another tricky thing that we're going to have is this should remain sorted by timestamp in order to make sure this plays out correctly. So, yeah, we're going to have to think about that too. Okay, anyways, though. Timestamp position entity. Okay, and then we're going to have this, but we also need to keep track of how many things we actually have in here. So what we can say is we have like this number of position commands, and that will be 0 at first. So then what we'll do is once we initialize our server, I'm going to do it after everything succeeds. We will say, actually, let's do it before everything succeeds because, wait, no, yeah, we'll do it after everything succeeds. Okay. So what we'll do is we'll say here position command buffer, and then what we should do is also say like static const expr int max number of position commands equals, and we'll do, I don't know, like 1,000 for now. So 1,000 times whatever the size of this is, that's 4 byte. No, that's 8 bytes, 16, or wait, 8, 12. That's another 8. So that's 16 plus 4 is 20 bytes. So 20 bytes times 1,000, that's 20,000 bytes. 20 kilobytes. Okay, so maybe we can up this to 3,000, 60 kilobytes. Voxorfs, apparently storing arrays separately rather than in single array of structs is more efficient somehow. Not sure why. Yeah, but I'm probably going to be operating on all this stuff at once. Like, I plan on gathering all this data at the same time. So I think, I don't know. I know what you're saying, and that's what I do for my ECS, but for this, I don't care right now, at least. Okay, we'll do 3000 for now. So then what we'll do is we'll say position command buffer equals G memory allocate size of position command update position command times max number of position commands. And then we'll say number of position commands. Nope, not that. Position commands equals 0 because we don't have anything. And then we'll just cast this to a pointer here and we're good. Okay. So we've got that. We've initialized to 0. We're all good there. And what we should do too, I guess, is we should say position command buffer equals null pointer here. That way we just initialize it to 0. And if it fails or whatever, we don't get bad stuff. Like it should crash pretty quickly. Okay. So yeah. Okay. So we've got that. Now we can start putting stuff into there and we need to make sure we put it in and it's sorted, which is also annoying. So also, how do we want to store the timestamp? That's a good question. How to store timestamp. And we want to make sure we store absolute value of the timestamp rather than deltas, because then a cheating client could send a big delta and then trick us into thinking different things. So anyways, yeah. Let's look at C++. Maybe not nanoseconds. We want to store it in milliseconds would be fine. Okay. So get current timestamp in milliseconds since 1970. I guess this is probably the best way to do this. And I think this should just be 64 bits, which is fine. Okay, so I guess we'll use this chrono. And this should give it to us. Yeah. What about this one though? This gives it to us in a 64-bit integer. And it looks a little bit easier. I don't know. I'll probably use chrono though, because I think this is technically the better way or whatever, right? Okay, so anyways, we'll just grab that. That's not what I wanted to do. And then when we get a command, we're going to attach the timestamp of when we got it on the server side, right? So we don't let the client actually send the timestamp. We just take it from whenever we got it. Is this? No, actually we do. So we're going to take the timestamp from the server or the client. Never mind, because we do need that. Okay. So when we're sending commands here, when we send a user command, if we're sending it to the server, what we're going to do is we're going to get the milliseconds. So we'll say stood chrono milliseconds equals duration cast to milliseconds to system clock now. There we go. Cool. So we get the milliseconds and then we're going to attach this to our command data or whatever, right? So this is where we get the timestamp. Yeah. So then what we're going to do is we're going to say, I'm trying to think if we'll attach the timestamp up here. I guess it doesn't matter too much. Okay. So we'll attach timestamp here. This will also be a problem in different time zones. I'll have to think about that at a different time because yeah, actually it might not matter. Well, yeah, it'll matter. Okay. Anyways. We'll worry about that at a different time. So we basically get this, and then we're going to say timestamp equals milliseconds dot count, which returns a long, okay, which is a 64-bit integer, right? And I think that's signed integer. Why would they return it signed? C++, what size is long? Okay, cool. So it looks like that is 64 bits. It just says long. It doesn't say int or anything. So is that a double or is that something else? I have no idea. 64 bits, yeah, but like what type is it? Because that's probably good to know. Also, on that note, whenever I get size t, I just cast that to int a lot because I don't care. And I'm guessing that's probably fine for most cases, but I'm not sure if that would be a problem because if you surpass 32 bits, of whatever that size is, and it's probably gonna be wrong. But yeah, that's just a side thing. Okay, we'll do this for now. So we just get it in milliseconds. Now when we send it to the server, it should have the appropriate timestamp attached to it, and we should be able to just sort things based on that. Okay, so then on the server side, when we get the message, it's gonna have that timestamp, and we want to add it to our buffer. So what we're gonna do now is we're gonna add it to our buffer. Instead of sending it immediately, we're actually gonna send these on fixed updates to the rest of the clients. Yes, I think so. And actually, we'll probably want to send the buffer to the clients so that the clients can interpolate and stuff too. I think. Yeah. Okay. So we're going to have to replicate this on both sides. So what we'll do is we will say we want to add this whole thing, what I call it, position command, update position command. Update position command dot entity equals entity ID command dot position. Okay, so what we can do too is we can actually just kind of unpack this data directly into this command. So we'll do that. Did I delete something I needed? No, that was all fine. Okay. Oh, I have two commands here. Buffer command. Okay. And then what we'll do here is we'll say buffer command dot position, buffer command dot entity, and then we'll say buffer command dot timestamp equals user command data, or no, just command timestamp. Okay, so now we have it stored inside this structure, and now we want to add it to our buffer. So let's add some helper functions for that. Okay, so we will have a couple functions to help us out with this stuff. Okay, so what we'll do is we will have static void add to buffer. And this will take in a const update position command, which I'm gonna need to declare. Let's actually put this inside the network because I'm gonna need this client side too anyways. So we'll put this up here. Okay, that should be good. Cool. So we'll do that command, and I think that's all we need. So let's go ahead and implement this. We want this to insert this into our array, but we want to insert in an ordered method, right? We want to put it in the right place. So how do we do this now? We basically need to loop through. Okay, so the simplest thing we could do is we could just loop through our array. I is less than number of position commands, I plus plus. We could do like a binary search, which would be a little bit faster since it should be sorted anyways. I can upgrade that anyways later. So we'll say to do a binary search instead of a linear search. Okay. Int index to insert at equals 0. I guess we'll say -1. So, or maybe we should say 0 because we might have 0 commands. So if we just say 0, then that will insert it at the beginning anyways. Okay, so anyways, we go through all the commands. Const update position command ref current command equals position command buffer I, and then we can just say if command dot timestamp is greater than current command dot timestamp. Yeah, we're going to sort this in least to greatest order. Position command buffer is sorted least to greatest. So if that's true, then we just need to look for the first command that we are greater than. Right? Yeah. So we find the first one that we are bigger than, and then we insert ourselves there. Okay. Now the question is, how do we insert this here? Do we insert it by moving everything to the right or by moving everything to the left? And I think we probably want to move everything to the left because we don't want to, well, yeah, we don't want to discard newer commands. We just want to discard older commands. So, gotta think about this too. Majorok, how's it going? And what game engine do I use? C++. So no game engine here. I use some libraries to help me out with different things, but yeah. And SE Woods, with the description you put under today's stream, you realize you have to finish multiplayer today. No pressure though, yeah. Well, I will finish multiplayer today, but I didn't say I'd finish it in the stream. And technically it is working, it's just not working good. So it's done. I'm just adding lag compensation, which is nice to have. So I don't even know if Minecraft actually has that or not, because I know it definitely doesn't have like interpolation, because players just snap to whatever position if they have like a lag spike or something. So yeah, we're going to hopefully do a little bit better than that. Yeah. How to play your game. Can we play with you? Well, multiplayer is working, but it's only working on LAN right now. So I don't have any sort of support for like public servers yet. Should be easy to add that once I get this updated, but I also need like a proper authentication scheme and everything if I was going to do that. So it requires a little bit more work than I want to put into it right now. Okay. So we get the index that we want to insert, break. Now we know where we want to put it. To do, well, actually, yeah, we want to move data to the left. We want to discard old commands. We don't want to discard newer commands because we want those to stay saved. So if we don't have room, that's what we'll do. But if we do have room, then we'll just put it here and then move stuff to the right. Okay. How to play your game. Can we play with you? Not right now. No. Oh, wait. I already read that. Yep. Should be easy. Famous last words. Yeah, I know. But it really should in this case because, like, as long as it works on LAN, it should work on a server, right? I don't know. Okay, so we need to put data to the right if we have room. So if number of commands +1, whoops, +1 is less than max number of position commands. So this means we still have room here. We don't need to move stuff to the left. We just need to move stuff to the right. So what we can do is we can say stood mem move. And then what we'll do is we'll say move stuff from number of position commands. Thank you for following. One happy balloon. Good to see you. Okay. Number of position commands. Or actually, I guess we should say position command buffer plus index to insert at. So we want to move that to 1 to the right. So we say position command buffer plus index to insert at plus 1. Size is going to be size of, let's move this to a new line. We'll say size of position command update or update position command times, and then number of position commands minus index to insert at. Okay. So that should move everything 1 to the right. And then we can just copy mem from, where do we want to put it? We want to put it at command buffer plus index to insert at. And we're taking it from address at command, size of update position command. Okay. So this should put it in the correct place. What's wrong with this? We can just cast this. This should be fine. Okay. So we just move everything to the right and then we put everything there. So that's good. But if we don't have room, we want to move stuff to the left, and then we want to just discard any old commands. So we'll say else, that was not right, else, we want to say stood mem move position command buffer +1 to position command buffer. And the size we want to move is going to be size of update position command times index to insert at -1. Yeah, I think that should be right. So we move that stuff to the left one is basically what we're doing. And then we can say gmemory copy mem update, or I guess position. This thing is going to remain the same no matter what. So we can just do that afterwards. Okay, so move data to the right if we have room. Otherwise, move to the left. And we only want to do this if the index is actually passed like in the middle of stuff, right? We don't want to do this if it's like already at the end, like this is the newest thing. So we should actually modify this a little bit. We should say if index to insert at is less than number position commands. Then we do this. Otherwise, we should set this to -1. And then otherwise, we can say if index, or actually, I guess we could just do that. Yeah. So if we loop through everything and we don't find anything, then this will be -1. So if index to insert at does not equal -1, then we do this. Otherwise, index to insert at, we're adding a new thing here then, equals number position commands. So if that's 0, we're adding it to 0. If it's 1 command, we're adding it to index 1. So that's good. And then what we can do is we can say copy it there, and then we can say number position commands ++. Okay, cool. So, and then I guess we should, well, yeah, so this should be fine. One thing we do have to check for too is if we're running out of room. So this will fail if the index to insert at is greater than or equal to the number of position commands. So let's actually fix this a little bit. Let's say if index to insert at does not equal -1, or it actually equals -1, we'll set it to that, okay? And then we'll say if index to insert at is less than number of position commands, then we do this. We move the stuff, but we also want to check if, or if index to insert at is greater than or equal to, I don't know. I don't want to do it here though. Okay. So we should say, or if index to insert at is greater than or equal to max number of commands. Right? So if we're greater than or equal to the max number of position commands, then we kind of need to move stuff back 1 and then not increment anything. Let's see. Then we need to say, okay, so if this is the case, we need to say index to insert at equals number position commands. -1. Or I guess max number, sorry. We'll do that. And then we can say -, we're going to remove something, and then we're going to put this at the end of it, so we move everything to the left. Yes. So we'll do the same thing here. So we'll say move everything to the left, index to insert at -1. Okay, so I think that should be good. That's all we need to do. Okay. Now let's check and see if this works. Probably not going to work because that's a lot of kind of complicated code, but we'll check. So yeah, SD Woods, currently working on cheat code for this game. Just reach out if you want. I'm sure Gabe won't mind. Nice. See, this is why I'm going to have to move it to closed source pretty soon. No, I'm just kidding. But okay, so right up here when we do this thing, what we're going to do is we're going to say add to buffer command. And for now, let's just comment all this stuff out. We'll work on this later. We just want to make sure that actually adds stuff to the command buffer and it doesn't overrun it. So go back down here. What I'm going to do too is just put a breakpoint in here at some point. We're going to start it, run it for a little bit, and then put a breakpoint to make sure that we're not getting... Actually, we should just start it and run it and see if it works. And then we'll make sure that we're not like breaking stuff. So yeah. Okay. Another thing we're going to have to worry about too is multiple different entities, because technically we only want to interpolate between a single entity ID's position. So we kind of need this to be like a map of buffers, which would probably be a little bit better. Okay, ECS is not a namespace. Let's just include core/ECS. Okay, so that should be fine. Sam check, just implemented the ambient occlusion. Oh, hey, can add it to your repo if you want to look. Yeah, another huge shout out to Sam. So let's see, is this going to work? I am human. Okay, click each image containing a bus. That's not a bus, that's a train. You know you've been streaming too long when you think a bus or a train is a bus, I guess. Okay. Okay, did I get that wrong? Bus. Okay. It doesn't think I'm human. Did I click on the right link, Sam? I think I did. Okay, click on each image that's a boat. There we go. Boats. Boat. I don't think it likes my browser. Maybe that's what it is. Let me put this into Google Chrome real quick. Also, but will I put it into closed source once I start working on the game? Yes, I will be moving this actually into closed source pretty soon. But yeah. Okay, there we go, Sam. Thank you. Gabe is a robot. Confirmed. I guess so. Oh, this one also requires the same thing. How's it going, Nelfs? That's why you use Imgur, I guess. Or Discord. You could just send it in Discord, Sam, and then I can pull it up here. Let's see. We did just boost the server, so we should have enough for this. But yeah, okay, so Sam was working on ambient occlusion, which is nice. So we should have that working hopefully pretty soon, which is super awesome. And I'm interested to see what you did too, because I know we had talked about some different techniques and stuff, and Sam was doing it a different way than I kind of thought of doing it, but it's always good to see different techniques. So yeah. Let's check and see if this works real quickly too, just because that's probably a good idea. So we do this and this. Okay, so let's hit play game, load world. Let's see if we get any crashes or anything once we start this. We won't see any position updates, so that's fine. So no position updates. We're not getting any crashes, which is also good. Let's go ahead and switch to where we were doing all this stuff, and we'll hit a breakpoint just to see what the size is and see if it's inserting it in the correct locations and everything. So let's go ahead. Let's put a breakpoint right here. Okay, so index to insert at is -1. Let's continue to here. Index to insert at is 0. So that already sounds wrong. How many commands do we have? 1647. Okay. What was the command we just got? So command looks like this. 1640. Let's just look at that too real quickly. So let's watch position command buffer, and then we'll look at like 30 of them, or 30 or 40. Okay, so if we take a look at this, are these in increasing order? No, these are all the same. That's not good. Okay, so already this is broken. Oh, and the entity is bad too. Yeah, so what's going on here? So position looks okay. Entity does look okay, actually. So that's fine. Oh yeah, and it makes sense that we'd be getting the same entity every time. But the timestamp, so that says 50. Oh, maybe I just don't have enough room here. Do I? Timestamp should be... Oh, this is for this one. What's this one? Yeah, okay, bad entity here and bad stuff here. Oh, okay, yeah, so I think the size is just weird. Wait, let's see. Number, position, commands. Yeah, 1647. Huh. Something's already wrong, though. Yeah. Nate7, thanks for following. Good to see you. Let's check out real quickly on here. Ah, okay, nice. So this is Sam's game. And the ambient occlusion. That's pretty epic. I'm trying to see. Okay, so you've got it on like the sides and stuff too. So is it directional in your game? I think. But yeah, that's pretty cool though. I like the look of it and everything. You guys should check out Sam's stuff. I don't know if you have any YouTube or Discord or anything. I think you've put YouTube channel in the Discord before, but you guys should check that out if you want to take a look. Unpacking error. I don't think it's an unpacking error. I think I'm inserting stuff at the wrong positions. So we loop through the number of position commands. Yeah, directional light plus ambient occlusion with PBR pipeline. Nice. That's pretty cool. Okay, so we've got index to insert at. Current command equals position command buffer. Okay, and then we are checking to see if it's greater than our timestamp. Then we insert it there. We say if it's -1, then we put it at the number of position commands. I think what I'm doing is I'm probably moving the data wrong. That's probably what's happening here. So let's actually just check and see if this all works good. The way Gabe makes it sound, he's checking, asking if the ambient occlusion is directional. Well, I mean, ambient occlusion is kind of directional because based on the sun's position, you're going to be getting different amounts of light in different areas of your scene. So, because the ambient occlusion is basically just what the sunlight, the extra light from sunlight. Ambient occlusion is not directional. Okay, one sec. Let me look this up again because I know we had this discussion last time. Ambient occlusion, Wikipedia. Okay. 3D computer graphics. Ambient occlusion is a shading and rendering technique used to calculate how exposed each point in a scene is to ambient lighting. Okay. For example, the interior of a tube is typically more occluded and hence darker than the exposed outer surfaces. Ambient occlusion can be seen as accessibility value that is calculated for each surface points. In scenes with open sky, this is done by estimating the amount of visible sky for each point. While in indoor environments, only objects within a certain radius are taken into account, and walls are assumed to be the origin of ambient light. The result is a diffuse, non-directional shading effect. Okay, so it is non-directional. That casts no clear shadows, but that darkens enclosed and sheltered areas and can affect the rendered image's overall tone. So unlike methods such as Phong shading, ambient occlusion is a global method, meaning the illumination at each point is a function of other geometry in the scene. However, it's a very crude approximation to full global illumination. The appearance achieved by ambient occlusion alone is similar to the way object might appear in an overcast day. Okay. So yeah, and then they start showing how ambient occlusion is based on the normals. In the absence of hardware-assisted ray traced real-time applications, use screen space ambient occlusion or horizon-based ambient occlusion as a faster approximation of the true ambient occlusion. Yeah. So basically, ambient occlusion is just the amount of light that is in the world. And then, Sam, you sent an image with how it looks without textures. Okay. Let's check that out real quick, too. Okay, nice. Yeah, so you can definitely see. That is pretty cool. I'm going to have to steal your code. No, I'm just kidding. But I'm going to have to see how you did that because I want to implement something similar too. Okay, let's start a server real quick and make sure that we can add stuff in the correct place. Okay, so we get this whole thing. Index to insert. We should have 0 commands. We have 0 commands. So we're just going to skip that. So then index to insert at is 0. If index to insert at is less than number of position commands, it's not. So we're going to skip that. If it's greater than or equal to number of max. Oh, I think this is where we're going wrong. Wait, no, this is right too. Okay, wait a second. So wait, I might just be, I'm missing the simplest case here. If index to insert at equals number position commands. So if we're inserting it at the end and number position commands is less than max, which we can get a little bit simpler by just saying else here and removing this. So if this is the case, we just want to copy it. Wait, which is what this should do though, right? Yeah. So this then should say position command buffer plus index, which would be 0. And then we say number position commands plus plus. Okay, yeah, so never mind. We don't have to worry about that. Okay. Sorry, that was working okay. Let's see how this works again. Jomega, ambient occlusion is basically if you light from all sides, how will the light return, or if it gets stuck in something like a corner? I mean, ambient occlusion is basically just like the ambient light, right? That's just the light levels of like how all the light in the entire scene is affecting it. Like in the real world, it's just like how all the lights in my room light up the corners of the walls and stuff. Sort of what you're saying, which is impossible unless you use ray tracing. So what they do is they approximate everything with all sorts of different techniques and stuff to just sort of give a fake ambient occlusion. Because unless you're calculating every single light bounce, you can't really get true occlusion. Okay, so this is 0. Okay, so we skip that, we skip that. We're gonna insert it at 0. So position command buffer plus 0. If we look at this, currently this is like this. So what we should see is this should populate with something normal. So we do that. Okay, so this gets populated with this, entity 2, position, blah, blah, blah. And then we increment the number of position commands. We now have 1 command. Okay, if we continue, we're gonna hit this again. So now we've got a command that looks like this. Yeah, it looks like the data is getting copied, all right. So 164.079.3322.6212, which is greater than what we've got there, I think. Yep, so it's greater than, wait. I might have this wrong too, because now it's going to insert it behind it. Okay, anyways though, if we do this, this should still let us see if this is working at least. Okay, so if number of position commands is less than max, it is. So then this should move 1 down. It did not. What happened? We moved this up. So we moved to the left instead of moving to the right. What am I doing wrong here? So we're saying move the position command plus the index. Oh, this is the destination. Move this over there. Okay. So we should put that there. Remove that. That's better. Okay. We want to move the stuff to the right. Yeah, 1 to the right is what we want to do. And I think I have this wrong too then. This means we want to move this. Otherwise, move to the left. So what we want to do is we want to move everything to the right of us, 1 to the left. Yeah, so this is wrong too. Okay. I hate how they have those flipped. Anyways, so that should be good. So now we're moving the data in the correct directions. But I also realized that this is wrong. We should be doing I+1 here. Yeah, okay, that's better. Because we want to insert it after the first one that we're greater than. Is that true? Wait a second. Yeah, after the first one we're greater than. Okay, let's check and see if this works. Block Builder YouTube, how's multiplayer going? We basically got it done. We're just working on lag calculations now. Or like lag compensation, I guess. So yeah. Amazing J, wait, you're moving all of them or just the one to the right of it? All of the ones to the right of it. So it should move like, if we have 2 commands to the right of it, it should move those 2 like 1 to the right. So I think that's what it should be doing. We're going to check and see if that's true. Okay, so we start there, we join here, we get here. So this should insert it at the first position. So 0 is this, and then 0 is now this. Cool. So then we continue. Now we're going to go insert it at index 1, which is good. So then that's fine. We're going to skip that. It's just going to put it there. Okay, cool. So now it's putting it there. And we should be good. Let's continue for a while just to let it fill up. That way we can see if it works once we run out of room. Let's see. And let's also move this guy out of here. Okay. So running for a while. Let's check and see what happens now. How many commands do we have? We have 989. Let's let it run longer. Whoops. Okay, let's pop these back open. If the windows are minimized, I actually don't do anything too. Like, so if the window is minimized, I don't update the game at all because there was a bug with that stuff. But yeah, it should, but is it? That's what we're going to check in a minute. So if we wait for this to fill up the command, it should start move everything to the left of it, left one. So we'll see if that's working. Okay, so let's put the breakpoint back in here. We now have, we should have the max number, hopefully. Number of commands, where is it? Right there. 2,797. Okay, so we're still not quite there yet. We're almost there. And this is good to know too. So this is queuing up like a lot of commands. This is much more than 1/10 of a second. So I should probably decrease the size of our buffer because this is like a lot more than 1/10 of a second. Okay. Anyways, let's check this now. We have 4,023. Okay, so this is already bad because I think the max number I have is 3,000. So we should never really go above this. Yeah, we only have 3,000 possible. Okay, so let's see what's happening here. Continue to here. And the reason we're not getting like a out of bounds error is because I have buffers around the memory to check for heap corruption and stuff, which we would see. But yeah. So, okay, so this is why. Oh, wait, okay, so it skips that, yeah. Okay, yeah, so then once we get to here, it should move stuff to the left is what it should be doing, but it looks like it's not. So we say, so what should happen is we should see basically all this stuff turn red. No, nothing turned red. Okay. And then this should trigger too. No, this isn't going to trigger either. Okay. Index to insert at is 1. Okay, why is it inserting it at 1? That's weird. I think we have several things wrong here because nothing is looking right. Okay. So let's go over this code again. So basically what we do is we look for the first command that we should insert this at. We just scan through it and then look for the first one where we're greater than it. And then we say insert it directly to the right of that. Then we say if we didn't find anything, we say insert it at the end of the list. Then we say if where we want to insert it is within the list. Yeah, okay, so if we're inserting it at the end, we should skip this. Otherwise, we check and see, do we have room? So if the number of positions commands +1 is less than the max, then we're going to move it to the right if we have room. Otherwise, we should move it to the left. So what this should do is it should say move. Let's just do a concrete example here. So we have like stuff here. Let's actually use an index like 12, 13, 14, 15. And then more stuff. Let's say we were inserting it here. So then this says insert it at index to insert at +1. So this is that 13. So we're going to move position command buffer plus this. So move everything from here to size of commands. We'll say this is the size of commands to here, which is what it should do. Oh, and then that's going to be a problem, isn't it? Is it? Wait, because we were inserting. Yeah, okay, this definitely isn't working right then because we want to insert it here. So what I should be doing is I should be moving all this stuff to the left of it to the left. Or like all this stuff should be going back one like that. And then we can put it here. Okay, so this is what's going wrong. Shouldn't those last two statements be swapped, by the way? Like these two that I'm sort of like figuring out right now, like should we swap these things? Because if so, I think you're right. Or are you talking about this stuff? Basically, I think this is wrong. We should be doing this here. Otherwise, we should be doing this. Well, I don't know. I'm going to have to think about this a little bit more. Okay. The greater than or equal to max number position commands should be before less than number position commands. Yeah, you're probably right on that one too. Because otherwise we're going to do some bad stuff there. I should probably have an else if in here somewhere. Like that or something. I'm probably going to end the stream right about here though, just because it's becoming hard for me to think critically, which means I've been coding for too long and streaming for too long. So I think it's becoming unproductive now. Let's see. If we uncomment this though, we do have like a basic multiplayer setting working. Actually, it's not going to work here because I have to do this, fix this real quick. So if we say buffer command, and then we do buffer command dot position and buffer command. There. What's wrong with this? Dot entity. There we go. So if we do this and just sort of re-enable the code we had before, we should have multiplayer still working all right, which is good. And all I basically need to do now is like add that lag compensation just so that it's a smoother experience for players. It's not critical. I mean, it is kind of critical if you want a smooth gameplay experience. But right now, it's not critical for me. So if I start this and join here, we should have basics working. Yeah. Okay, so yeah, you can see I'm moving around over here. If I place blocks, they place on both of our screens. So that's good. And then if I break them, they break on both of our screens. The time is wrong and stuff. I still need to fix that. And this goes both ways too, right? So if I move over here, it all works out too. And then if I place stuff here and break stuff here, it all works out too. So we have multiplayer stuff working. The chunk loading and unloading just isn't going to work properly right now. But that's something that should, I'm not going to say should be easy to add because it's not going to be, but it's something that I'll be adding in a little bit. I'll probably work better on this if I'm not trying to think about streaming at the same time. So I might, so that's probably why I'm going to take it off stream. Anyways, SE Wood, so what will you name the next stream? finally finishing multiplayer? No, I'm going to name it Multiplayer is Done, and I'm just talking about what I did. That's the name of the next stream. But yeah, thank you everybody who was able to come today though. Hopefully you enjoyed it. Hopefully the beginning of this was at least helpful to you guys. And then we're going to add in like the rest of lag compensation, everything. But yeah, thanks everybody. I will see you guys next time.